Welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to talk about Incus Docker containers. And there are now 3 types of Incus containers as of Incus version 6.3. Incus containers are Linux containers or LXC containers that have a CLI and an API in front of them, just like canonical LXD. And Incus virtual machines are really QEMU virtual machines, but they benefit from the same API and CLI capabilities. And then Incus Open Container Initiative, or OCI, are the brand new containers, and they're simply Docker application containers that can be created in Incus. So overall here at the top of the screen, you can see the Incus server host, and of course that's running whatever operating system you've hosted your Incus on, whichever Linux variant. And then inside of that, you're going to have the Linux kernel, which of course interfaces with your hardware. So the first type of container that we have, which is the type of container that was initially provided from LXD and Incus, are Incus containers. And we have this overlap the Incus server host here to indicate that Incus containers are very lean and efficient because they share the Linux kernel of the Incus server host. The second type of container that we have are Incus virtual machines, and they use a software kernel because they virtualize the operating system, but they also virtualize the hardware, and they're kind of the heaviest weight type of container, but they are needed in some isolated situations where you need to be able to have control of the hardware. And then finally, our newest type of container are the Open Container Initiative containers, or the Docker containers, which we can create in Incus, otherwise known as Incus application containers. So let's go off and see what we can do with this new type of container. Here we are on my newest Incus server named Demo-1, and I want to thank my subscriber Calvin for his very generous contribution of this server, which is an Intel Atom with 8 cores running at 2.4 gigahertz per core, and we presently have 32 gigabytes of memory in this particular machine. I have installed Incus 6.3 on this machine using my video entitled Incus Containers Step by Step, and I could do an Incus space version to show this. And it's important to point out that Incus version 6.2 and before does not have the new Docker OCI containers that I'm going to be featuring in this video. So if you haven't yet updated, go update to Incus version 6.3. Incus provides us an increasing number of options every time we get a new upgrade, and you can certainly install Docker packages in an Incus instance like I have on the channel before, but that would put you in a situation of running a container inside of a container. And I don't really see that as a bad thing, because really there isn't an awful lot of overhead in doing that. So in Incus, you typically run system containers, which are containers that have been set up to resemble a virtual machine. That is, you end up launching a system container in Incus, and this system container keeps running until you stop it, just like a virtual machine would. And Docker is a little bit different, and I know it doesn't really appear as so, but with Docker you're running multiple application containers, and those application containers, as opposed to system containers, typically run with some configuration. They perform a task, and then after the task they go ahead and exit and the container stops. And they might have some sort of a Docker container which is long-lived, and that's more what you think about in general, something like a web server or some of the other applications that I've presented on the channel. In that case, the application container might have a longer lifetime. It might stay up and running because it's running a particular daemon that people connect to. And so with application containers, you're thinking primarily about running a task and not an operating system. And when you stop that particular task, the container goes away, and when you create the container the next time, it's creating a brand new container. And so if you haven't stored your data persistently, then the data is lost between runs. So typically on the channel, I have created a dedicated Incus container. I end up installing Docker into that container, and then I've configured an application using Docker Compose. And I kind of like that use case because it keeps all of the containers for one application on a single Incus container, and I like to present that container on its own dedicated LAN address using the bridge profile that I defined in Incus container step by step. So here I have an example of a Docker Compose file, and it has a services section. So the first service here is called change detection. The second service is called playwright-chrome. In general, each service turns out to be a Docker container image. So here's one of the Docker container images for this application, and here's the second Docker image for this other service. So in general, when we're talking about Docker Compose, it runs multiple containers, and those are divided into what it refers to as services. Docker OCI containers operate much more like the Docker run command, and that means that the OCI containers end up running directly on your Incus server. And by default, they use the server address of the Incus server when we expose them to be connected to externally. However, as you're going to see in this video, we have options. Back on the new Incus server running Incus 6.3, we want to look at a couple of things before we start. And one thing we have to do is do an Incus remote list, and this gives you the names of the repositories that we can create images from. By default, when you install a new Incus server, you're going to have the local machine, which is really just yourself, and you're going to have the images repository at linuxcontainers.org, and that repository is where you get all of the Incus containers and Incus virtual machine images. Keeping that in mind, Incus version 6.3 by default has no way to load Docker images. And we know that by default with Docker, Docker images normally come from the Docker Hub, and there have actually been several other Docker repositories defined as well. So we have an Incus command here called Incus remote add, and I'm going to call the name of my repository Docker. You can actually call it anything you want, and then we're going to say https://docker.io, where the protocol is OCI, standing for Open Container Initiative. Once we do this, it goes ahead and adds the new repository to our remote list, and if we do an Incus remote list, we now see the Docker repository as one of our repositories. It might be a good idea to name your repository Docker, as I have here, and the reason is when you create containers, you're going to refer to this name in order to pull images from that location. I do not yet have any Incus containers on this Incus server, and if I do an Incus list, we can verify that. So let's create our first Docker OCI container, and we're going to do that with an Incus launch docker:/jgraph /draw IO, and that's the draw IO application. I'm simply calling it draw, and I'm using the default profile and also the bridge profile that we learned about in Incus containers step by step, which will present our draw IO instance out on the main LAN with an address on the main LAN. Now that our draw.io container is started, we can do an Incus list, and we'll see the address on the main LAN of 172.16.1.164. And by default, this application presents itself on port 8080. So if we go into our web browser and we go to 172.16.164:8080, we go to draw.io and we can launch the application. The advantage to bridging this to its own address on the main LAN is we didn't have to worry about whether or not port 8080 was used by another application. We can also launch another instance of draw.io, and this time we'll call the container draw-2, but you see I'm not providing any profile information here when I launch the program this time. So now if I do an Incus list, the difference is that draw-2 is running on an internal NAT address for the Incus application. The draw2 container that we now have up and running runs very similar to what we get in Docker by default when we run a container, because it runs on the Docker internal network. And you'll recall that there's usually a ports directive in both the Docker run command and the Docker compose command. So the equivalent to that in Incus is this command called Incus config. So we can say Incus config device add to the container draw2, and I'm just arbitrarily calling this host port 8080, and I'm going to say it is a proxy, and proxy is one type of device you can add, and I'm saying connect to 127.0.0.1, which is the local container running inside this address, the loopback address, if you will, and port 8080, since that's where I know that the draw2 application runs. And so then we have a listen port of 0.0.0.0, which means that anyone can connect, and I'm again offering it at port 8080. We could of course change that and make that port number anything that you want. And so we get a permission denied error here, and I think that's a shortcoming of certain applications, but it is possible to get around that. Not all containers will run into this type of error, but this particular container, probably because of the resources that it's using, is running into this error. So one way around that is I can run this as a privileged container by doing an Incus config set draw2 security.privileged equal to true. And now that I've done that, I can do the Incus config device add draw2 and add the proxy to that container successfully. And now it's still giving me the error, and I think that's because I'm going to have to do an Incus stop on draw-2. Incus stop on draw-2. And now that I've done the stop, I can go ahead and apply the proxy, and it adds it correctly. And then after that, I can do an Incus start on draw-2, and it should start correctly with the proxy simply because we have it set to privileged. Now that we have the proxy correctly applied to the draw-2 command, you can do an Incus list, and you won't notice anything any different because the proxy has been applied. However, we're going to do an if config, and here we're going to look at the address of my bridge 0, which is 172.16.1.226. And now our Draw2 application is going to be offered on this address at port 8080 in virtue of the proxy. And here we are at 172.16.1.226, port 8080, and there we are back in the Draw.io program. The downside of using this particular approach of presenting the application using the port proxy is the same disadvantage you have of running all of your Docker applications on one Docker server, and that is that all the applications have to use unique port numbers. And so if you have 2 ports using port 8080, you'll have to provide them on unique ports, and that is something I call port hokey pokey. So now if we do an Incus list, we have 2 containers, one named Draw, which is bridged to the main LAN using the bridge profile. The second one is Draw2, and that's presented on the internal network for Incus, and then we use the proxy to make it available out on the main network through the address of the Incus server. So another approach that we can use is that we can create a network in Incus. And in this particular case, I'm going to create a network that I call OCI. I'm going to say Incus network create OCI, where the type of that network is MAC VLAN, and the parent is going to be bridge 0. So now it says that network OCI has been created. And so then we can go ahead and create a container that uses that network by doing an Incus launch, Docker, jgraph, Draw.io, same as before. This time we're calling the container draw-3, and we're saying --network is OCI. And now that the Draw3 container's been created, I can do an Incus list, and you'll notice that Draw3, just like Draw, has an address on the main LAN of 172.16.1.222. And since this address is a unique address and not using the address of the Incus server, we know that port 8080 is available. So we're going to 172.16.1.222:8080, and here again is the Draw.io application. One thing I want to point out about Docker OCI containers in Incus is if you look over here to the type column, you'll notice it doesn't just say container, but it says container app. And when you see that app in parentheses, that's how you know that you're dealing with a Docker OCI container as opposed to an operating system instance container, which will just say container. What if a Docker application contains multiple containers? For example, maybe one container that's a web server, another container that's an app, and another container that's a database. How do we handle that using Docker OCI containers? And the answer to that is that you would have a separate application container for each individual application. In the second part of this video, we're going to illustrate how that works with multiple Docker OCI containers by creating our own self-hosted instance of the Ghost blogging platform, which is an open source application that allows you to create your own blogging server. Just so that I don't have to play port hokey pokey, I'm going to delete our 3 Draw.io example containers, and I can do so by doing an Incus stop on Draw-2 and Draw-3, and it will stop all 3 of those containers, and then I will do an Incus delete on those same 3 containers. And now if I do an Incus list, we've started with a blank slate, and we can begin installing the Ghost application. Just to have a point of reference and to understand the differences between using Docker Compose and using an Incus Docker OCI container structure, let's go ahead and do a nano of docker-compose.yml. I don't have Docker installed on my Incus server at the top level, which is a best practice, but I'll just show you an example here of the Docker Compose for this application. So we have a services section. We have two application containers, one called Ghost and one called DB for database. Ghost is running an image called Ghost, and it's grabbing the latest tag for Ghost, and then it's running an image for the MariaDB, Maria database, and it's grabbing the latest image for it as well. Since we can't use Docker Compose, I'm going to go ahead and exit the editor and not save those results. And now we're starting from a blank slate, and just as a reminder again, if I do an Incus list, we do not currently have any containers running on this Incus server. If you're a frequent watcher of the channel, you know that we normally use Incus launch to launch a container, which really means creating the container and starting the container. There's also another command called Incus init, which creates a container and does not start it. In this case, we're going to use a very similar command, just with a different keyword, and it is Incus create, and that creates the container but does not launch it, just like Incus init. So here I have Incus create docker :ghost :latest. I'm naming the name of the Incus OCI container Ghost, and then here we have a series of environment variables. So normally in Docker Compose, we define the environment variables in an environment section, and in Docker Run, we do kind of the same thing. Well, with Incus OCI containers, we say -c, which is a command option, and then we say environment dot the name of the particular environment variable. So in this particular case, we have environment.url, and here I have http://172.16.1.226, which is going to be the address of my particular Incus server. And you would substitute in here an HTTPS address if you had offered it out on the net and you had yourself a subdomain name and you were using Nginx Proxy Manager. Next, we have here the database client being MySQL, and so on down the line. We have lots of different options, including the mail options that I've got listed here. So I'm going to go ahead and create this container in the background, and we'll be right back. Recall that I created the Ghost container, but I did not yet start it, and that's because Ghost requires a database. And so the database container I'm going to create with an Incus create docker Maria database, and it's the latest. And I'm going to call this container ghost-db for Ghost database, and then it has a series of environment variables, part of which are the environment variables for the usernames and passwords for the database, which the Ghost container will use. Recall, as we mentioned earlier, that Docker containers are volatile, and that means that when they stop, they lose all of their data. So the only way to have persistent data is to have volume mappings. And volume mappings are pretty straightforward in Docker Compose files, but with Incus OCI Docker containers, they're going to be somewhat different. So the first thing that we're going to need to be able to do is to create the folders that we're going to need for those persistent storage areas. And one of them that I'm going to create is going to be called the content folder, and the other is going to be the MySQL folder. And so MariaDB is a MySQL variant. We're creating both those folders inside of a Ghost folder. And now if we do an ls, we now have a Ghost folder with those two subfolders inside of it. Those folders had to exist before we can do our non-volatile volume mappings. And so how we accomplish a volume mapping is with an Incus config device add, and this one's for the Ghost container, and I'm just calling this arbitrarily content. I could have called this anything that I wanted to, but since it's going to use the content subfolder, I decided to call it content. The type of this is a disk, and then the source is going to be in /home/scott/ghost/content, which is the folder that we created on the Incus user account that I'm using, the Scott account. And then inside the container, we're going to var-lib/lib/ghost/content. And then the shift equals true is very important, because what that does is it provides the ability to provide write access from inside the container to outside the container. So now it says that that device content has been added to Ghost, and our new device called content is actually a volume mapping. Since I did not present this Incus container out onto the main LAN, it has a NAT address, and we'll see that when we start it. But the next thing that I need to do is to be able to provide a port proxy, just like we did with the draw container. And so I'm going to do an Incus config device add Ghost, and I'm just calling this thing arbitrarily host port 8080 because that's kind of what it is. And I'm using a proxy that's different than a disk directive, a proxy directive. And again, I'm saying connect from the loopback address at port 2368, which is where Ghost runs. And I could have provided it to port 2368 up on the Incus server, but in this particular case, I'm going to provide it at port 8080 just to show you how you can remap a port number. At this point, our database container also needs a non-volatile volume mapping, and to add it, I'm doing an Incus config device add ghost-db, that's the name of the database container, and I'm just calling this GhostDB because it seemed like a good name. And then it's going to be of type disk. The source is going to be on the Incus server in /home/scott/ghost/MySQL, which, as if you'll recall, was where we created that particular folder. And then the path is going to be inside of that database container in /var/lib/MySQL, and again we're doing a shift equals to true, which allows the container to write back out to the Incus host. One thing about the configuration of these two containers on the NAT is that we've isolated the database to the NAT network inside of Incus, and so it is not accessible on the main LAN, and that provides additional security to the database, which is only communicated to through the Ghost application container. And the Ghost application container is proxied to the main LAN so that our users can access the application. At this point, the only thing that remains to be done is to start the application. So we want to start the database first, since the Ghost application uses the database. And so I can do an Incus start on ghost-db. And then we want to go ahead and do an Incus list to make sure it's up and running. And sure enough, it is. And you'll notice that it has an internal NAT address of 10.85.91.60. And then the next thing that we want to do is we want to go ahead and start the application, and we can do an Incus start on Ghost. And now we can do an Incus list again, and you'll see that both applications are up and running, and both applications have NAT addresses. At this point, there's a couple of things worth mentioning, and that is that the Docker OCI container option that exists in Incus version 6.3 is in its infancy. And there are a couple of things that they have not yet implemented as of the end of July of 2024. And one thing that they don't have is a restart policy. So there's no way to set a restart policy where you say restart unless stopped or restart always. There is no way to do that currently. The second thing that you should be aware of is that there is no depends on option. So basically, you have to start the database before you start the application itself. And in general, once it's initialized and that's taken place, it probably won't have an issue because the application should be up and running and work fine. But initially, when you're initializing the database and making the initial connection, we want to be sure to start the database before starting the application. But we can only hope in the future that they'll have a depends on option so that the container will be able to start in order. So here we are up in my web browser, and I've entered the address 172.16.1.226, which, as you'll recall, is the address of the Incus server, and I'm using port 8080 just like I did with the Draw.io application. But since we deleted the Draw.io application, I was able to reuse port 8080 as my proxy. If I had the Draw application still running, I would have had to have proxied to a different port, just like you would do in running multiple Docker applications on the same Docker server. So here we go to 172.16.1.226:8080, and here we are at the Ghost application. This is not meant to be a video on the Ghost blogging application software, but you can go up here to the URL and you can type in /ghost at the end, and it will give you the registration screen. So I could say something like the Scotti-BYTE blog. I can type in my name, Scott Thompson, and I can type in my email address, vmsman@gmail.com, and then it requires a password of at least 10 characters. So I think that's probably 10 characters. And so I can say create account and start publishing. First of all, it says customize your design. I can come in here and go ahead and save that setup. Go back to the home page. And let's see, go back up here and go to the second thing, explore the editor. So I can say test post, say something like this is a test, and I can say publish and continue and publish right now. And then I can go back up and it'll show me my posts. And if I come back here to the top level, I can say build your audience, add myself as a member. It goes ahead and does that, and it will also send me email because, as you noticed in the configuration, I set up the SMTP server information. There'll be more on the notes about this, and I'll kind of specify a little bit more about this application. But as I pointed out, we're not really going after how to install a particular application. It's just that Ghost seemed to be a good example program. To sum all of this up, I went ahead and created two new Incus containers, one called test-1, which is a standard Incus container which shares the operating system kernel of the Incus host, and the other called test-2, which is an Incus virtual machine that has a software kernel. And then we have the two Docker OCI containers for the Ghost application that we've just discussed. Since this is really a first release of Docker OCI containers in Incus, I look forward to seeing what future options they're going to have available using this capability. And for right now, I kind of like nesting my Docker applications inside of an Incus container only because it allows me to keep all of the pieces of an application in their own separate container. However, I can see a compelling case where you might want to be able to do something like this, and so I wanted to provide both the option of running a single container with draw IO or a container that spoke with another container, as in the case of Ghost along with the Ghost database, because that is another option. So in summary, Docker containers nested inside of an Incus container are applicable for use cases where you have multiple Docker images. And OCI containers are a nice way to deploy a single Docker image. And OCI containers are generally presented on the Incus host address. And I've shown a way to create a bridge network to present OCI containers on their own LAN address. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell for all of my new content.